recording. The voice is good. It is recording from the correct screen. So this is kind of our main focus today is to talk about exam 2 from the previous semester. Um, and I'm doing it on a tablet so that that way the way I write is gonna at least resemble a little bit of how you guys need to write too. All right. So do we have any questions about past topics like what the video recording talked about on last Wednesday? No questions about that. So the resolution concepts. Yep.
I have a little bit of a question.
Okay.
When it talks about the priority of
Operators.
priority of operators, you put implications at the bottom.
Implications as at the bottom, which means even or has a higher priority compared to implication.
That's right. So when you're suggesting that you weren't talking about which ones to take care of first when we're trying to turn it into a CNF, were you? You're just talking about how they relate to each other when performing or when
Correct. So in the lack of parentheses, which ones need to occur first, and then which other ones will occur second, and so on. So if I give you enough parentheses, then the priority would not matter. Yep. All right. So let's go ahead and get started with the exam 2 from the previous semester. Your exam would have almost the same instructions, which means it is open book and open notes. Just like in the first exam. Okay, so I hope you guys have been kind of stockpiling material in your own notes for the second exam. If you have not, you still have more than a week to do that, which is actually quite a bit of time if you plan to use that time wisely. All right, so our exam time obviously is not going to be noon to 1:20. It's going to be 3 to 4:20. So it is still the same amount of time, which is 80 minutes. If you need DSPS accommodations, then you need to arrange for those in the time frame that the DSPS department requires. Most of this stuff still is the same for both of the for this exam for you. Um, so we'll go ahead and move on to the next page. And of course, okay, it does work. Okay. So this is question number 1. So question number 1 is you are given a relation R, and R is 0, 0, 1, 0, 2, 0, 2, 1, defined over X, and X has 0, 1, 2 as elements. Within the scope of this question, with this in italic, which means this does not cross to another question, define function C0 Rx being this and C1 Rx being this, and answer the following parts. So once again, I know some people are going looking at this and go like, oh, another notation kind of thing. Well, that's kind of the main theme of this class, okay, is notations. Notations like this is really important because when you move on to a 4-year university, some of the courses will assume that you already understand all of these notations. They won't spend much time to review the notations. So that's why in this class, I'm trying to get you guys to be as familiar with the notations as possible. So we'll take a look at C0 first, and then try to figure out what it is trying to say. So R is the relation, X is the set that contains the elements. This R really does not have much to do with this R over here. This X really does not have anything to do with this X over here. They're just coincidentally named the same, because this is just a parameter which is going to be used over here and here, and this is just a parameter that is used here and here. So that's basically, this R and this X here are really just parameters that I use in the expression here. So we'll go ahead and talk about this, okay? So first of all, we are creating a set, okay, that is indicated by this pair of braces. This is the opening, and this is the end here. So what kind of elements are we creating in this particular set? Okay, so in this notation, this portion here, which is the portion that is to the left-hand side of the vertical bar, is telling you the format of each element. So every element in this particular set that we're constructing is going to be a set itself. So we are creating a set of sets. Okay, we will have each element itself is a set, and specifically with two elements too. So now the question is, okay, so what two elements do we include in each element inside the set that is actually returned by C of 0? Well, we got some restrictions. E has to be from X, F has to be from X, and it is not the case that ERF implies FRE. Okay, so that's what this is requiring. Yes.
So that means that everything in the set is not commutative, or the R is not commutative.
R is not commutative.
Because it's saying that, oh, wait, never mind, that's implied.
Not necessarily. Okay, so we'll talk about this, when we actually plug in, the set that we are concerned about here. So this is the first one, and this is the second one. And this one is different because when you look at the format of each element in the set that is returned by the function C1, each one is a two tuple. How do we know? How can we differentiate between a tuple versus a set? Parentheses in here and braces over here. So you have to pay very close attention to how each element opens and how it closes. All right, so we are talking about two tuples here. So what restrictions do we want to place upon the two tuple or the elements of the two tuple? It is not ERF and it is not FRE, and E has to be in X and F has to be in X. Okay, so those are the restrictions. So answer the following parts. If C0Rx is a 0, which relation property is confirmed about R over X? Okay, so let's take a look at this. So what we want to do is to ask, what makes this an empty set? In other words, this set from here to here, what makes it empty? In other words, what will make this conjunction always false? Is that okay? All right. Well, the easiest thing is, we'll pick, if X is an empty set, then, then we're good. Because if X itself is an empty set, E belonging to X and F belonging to X has to be false anyway. Okay. But that would not be very useful. Okay. Because we are trying to confirm relation properties, about R over X. So the first thing you need to do to answer questions like these is to remember, what are the properties that we are talking about. Well, if you cannot remember, at least in spring 2024, I even specify that in no specific order, the properties of a relation are transitive, reflexive, comparable, antisymmetric, and symmetric. Now, you should not rely on me to put this in the exam itself. Okay, so I would suggest that you actually maintain in your notes, okay, what you bring to the test, to also have all of these properties of a relation kind of outlined so that it's easier for you to recall that. Okay, so we look at this and go like, it has implication involved in here, and the implication has to do with ERF implies FRE. So if it is without the negation here, that would have been at least related to which property? Right, go ahead. Symmetry. Okay, so symmetry is sort of, okay, but not entirely. So when you have a kind of recollection and you suspect, it has to do with something, then what is the next thing to do? Starts with a D. The way you answer any question in any exam is to relate the question to definitions. Okay, definitions. So what is the definition of, okay, let's pick the ones that are clearly not the case. Let's pick reflexive. Why do you think that this has nothing to do with reflexivity at all? Because being reflexive has to do with how each element relates to itself. I do not need F, okay, as a second element to describe whether something is reflexive or not. Okay, so we can just kind of go like, okay, it has nothing, probably nothing to do with being reflexive. What about transitive? Yes.
Are you saying that E should be different than F?
Hmm?
Are you saying E should be different than F?
Well, there's nothing that's, they have to be different because otherwise, they cannot be two different elements in a set, right? Okay, so if E and F are two elements in a set, they cannot be the same because of the restrictions that we have in a set. Elements cannot be duplicated in a set. Okay, so we can now say, okay, so I'm just going to jot down some notes here, and you can do the same in your answer. Okay, because if anything, it shows you your reasoning. So we can now say that, okay, this is not reflexive. It's not, has nothing to do with reflexive. And of course, when it does matter, it's not working. We were just talking about how technology does not work when you need it to work. Alrighty. There we go. Okay, so it is working. It's just, kind of needs a refresh. Okay, so it has nothing to do with reflexivity. Okay. What about the other ones? Which one can I kind of cross out almost immediately? Transitive. And why can't I cross out transitive right away? Because in order to describe whether a relation is transitive or not, how many variables do I need? We need three, okay? Because E, RF, and FRG, implying ERG, is what we need. So if you're hearing what I said, but cannot associate it with any definitions, then it's telling you that you might need to review those topics. Okay. So anyway, so in this case, we kind of know that transitive is probably has nothing to do with this part. So once again, I don't know why it is not refreshing on its own. Mm, now it's like completely okay. It's okay. So now we know it's not transitive. Um, so we don't really have a whole lot left. Okay, comparable has nothing to do with implication, so it's not comparable either. So what is left is really anti-symmetric and symmetric. So out of those two, symmetric means basically the way we define it is ERF if and only if FRE. And this is the kind of the negation of that, but this one does not say the negation of ERF if and only if FRE. The implication only goes in one direction. Well, it only goes in one direction because EF are in a set. Because if I were to do in both directions, it would not have changed anything. So basically C of 0 is capturing um, two elements of X where their relations is causing us to conclude that the relation is not symmetric. Okay, so if it is 0, so the proper answer to this question is symmetric, that R is symmetric. And unfortunately, I have to manually refresh this every single time. There we go. All right. And then what about the next one? Okay, what about this one over here? It says we want a tuple, which means ordering is important in this case. So EF is a two tuple, where ERF is not, it's not ERF, and it is not FRE, and E is in X, and F is also in X. So what are we talking about here? So E and F, yeah, go ahead. Hmm? It has to do with comparable. Okay, it it will give us two elements, where these two elements will give us reason to believe that um, R is not comparable. So when we have a lack of those evidence, then R is actually comparable. So that means the answer to this question is R is comparable. Okay, so, and I need to refresh this manually. Don't know exactly why. May have to do with the browser. Okay, I can try a different browser and see if that fixes the problem. Hmm. Or not. I'll just kind of refresh it. All right. So now it is asking, for 35% of the score for this question, it is asking about this particular R and this particular X. If I am to apply C of 0 to this particular R and this particular X, what is it? Okay, so now you have to pay attention, okay, because my own son, who was taking this class, last semester, or I think that, yeah, last semester, he did not read the question carefully, and he only, indicate a part of what he thought was what I was asking, and he got like a lot of points, deducted because of that. So, what is the answer? Okay, first of all, what kind of an answer am I asking? I'll give you three choices. The first one is I'm asking, describe, R over X as reflexive or symmetric or anti-symmetric. Okay, that's choice number one. Choice number two is a zero or non-zero. Okay. Number three, you have to give me a set. So out of the three, which one do you think is the format of the proper answer? Hmm? A set. That is correct. The third option, because I'm asking about what is C0 applied to R and X. So you have to give me the entire set. Is that okay? So now the question is, what is the answer to this particular one? So if I were to apply this R and this X to C0, how do I find the proper answer? Well, there's the long way and then there's the short way. Okay. The long way to do this, which is what you might need to consider doing at least a few times before you feel comfortable and go like, oh, okay, I know what I need to do. Now I can start to shortcut it. So uh, the long answer is to come up with all the possible two element set over here that meet this requirement. Okay, at least this part of the requirement. So we are looking at every possible way to pair up elements that are not the same. But ordering is not important because we are talking about sets. So we are talking about, okay, because of the my player is not updating itself, so I am going to switch my strategy a little bit and use my notepad to capture the answer, because otherwise, it's not going to be easy for you guys to read it. So let me just kind of get my editor to the right size before I put it on to your side. Okay, this. Ah, I'm trying to get my editor over to the other window. There we go. I cannot do it quickly because somehow my Bluetooth keyboard. Oh, okay, I can use my regular keyboard first and then switch back to my Bluetooth when I need to type. All right. So this kind of fits okay. All right. So we look at all the potential elements. In other words, here we look at C0 of Rx and we look at all the potential elements. Well, this part is a really good big restriction. E has to come from X and so is F. That really does not limit what kind of elements we are looking at. So 0, 0 is not a choice here, okay, because you cannot have duplicates. So 0, 1 is 1, 0, 2 is 1, 1, 2 is 1, and that's it. Those are the only three possible elements in the sea of 0. Okay, first of all, does that make sense? Is that okay? So then what do? Well, you just cross out the ones that do not fit the third requirement. This is the first requirement, okay? E has to come from X. Second requirement, the other element has to come from X. And then the last one is ERF implies FRE has to be false under what R, how R is defined. So R is defined like this, for this particular one. So, so we look at 0, 1 first. ERF, okay, 1, 0 R1 is false, 1 R0 is true. Is that okay? Now, because it is a set, so that means, if this implication is false, okay, it has to be false for both in order, for EF to be here. And because we have one but not the other, so 0, 1 has to stay in this particular set. Let me describe it one more time, okay? Because if, okay, so if EF is, okay, E equals to 0, F equals to 1, okay? So this is one consideration. So now the question is, what is the negation of ERF implies FRE? All right, well, we just have to figure it out. So ERF is actually false. FRE is actually true in this case. Is that okay? Because 1, 0 is in R, but 0, 1 is not. Are we doing okay so far? And the negation of this true is false. But what if I just change the way I look at these things and I look at it this way? So I look at E as 1 and then F as 0. And then I try to answer the same question, which is we are looking at the negation of ERF implies FRE. In this case, we are looking at the negation of, there's a true here, implies a false over here. The implication itself is false, so the negation of that is true. Okay, so let me just kind of pause here and see if we are okay with this observation. Are we good? So how do we relate these two? Because E being 0, F being 1, and E being 1, F being 0 is the same set. So so let's go back to the original question, which is the set of 0, 1. Does it meet this requirement or not? It meets the requirement. There's an implicit for all, kind of stated here. So for every way to have E and F, so that means, it is, if one of them is false, the whole thing is false. So that means 0, 1 does not meet this requirement because there's one way to look at 0, 1 as a set so that this requirement is not met. Okay, so I'm going to pause here and see if we're okay with that concept. How do we know there's an implicit for all? Okay, so this goes way back to the notations of how we describe elements or membership of a set. Okay, so I'm going to go all the way back to that point. Yep. Okay, so if I say something like this, okay, every element is X, looks like an X, and we have a predicate P applying to X here. So basically what this is saying is um, in order for something to be a part, to be a member of the set, P of X has to be true. But it is a if and only if. Okay, so that is when we talked about stuff, way back in at the beginning, right after we talked about quantifiers. So this actually is equivalent to saying for each X, okay, um, X is a member in the set. Okay, I need to give a name to the set itself. So we'll just say this is set A. Okay, so X is in A if and only if P of X is true. Now the is true part is actually redundant, but I'm going to call that out anyway. Is that okay? Do you remember this particular definition of this notation, A equals to X such that P of X is true, is equivalent to saying for each X, X is in A if and only if P of X is true. So do you vaguely remember that? So we have to apply that method when we look at this C of 0 definition. So we have to say for every way to look at 0, 1 as a set, this part here has to be true. Which means if in one direction this thing is true, but in the opposite direction this thing is false, the false makes the whole thing false because it is the two things are actually joined by a conjunction. So that means 0, 1 cannot be in the set. Are we still doing okay so far? Yep. Hmm? Um, well, there are things that can be in the set. In this case, nothing can be in the set. You're correct. But only in this case. Oh, it's actually pretty easy because as long as ERF. Okay, so we want this implication to be false for something to be in the set. So that means um, if I have a 0, 2 here, then 2, 0 as a set would satisfy this requirement. If you need both of them to be false, okay, so this is a negation, so we are looking for the implication to be a false. In order for the implication to be a false, it can only be a true implying a false. So you are correct. In this case, it is an empty set. So would it still be spelling out whether it is symmetric? If the set is empty, R is symmetric. Okay, I have to think about that a little bit. I think it really boils down to the interpretation of this when P of X so when this is a 0 and this is a 1, okay, I have to think about this a little bit. But we can at least try to answer C1 first, and then we can go back to the other one. So C1 is a little bit less conspicuous because this one also has a requirement that E has to be in X, F has to be in X, but because we are looking at tuples, so the potential elements with a C1 are X. In this case, it's just going to be potentially it is 0, 0, 0, 1, 1, 0, 1, 1, 1, 2, 2, 1, and 2, 2. So there should be 8 elements. I'm missing one. Um, 2 0. Okay, right. So it's 2 0 and 0 2 also. There we go. Okay, so these are the things that we have to potentially think about. And then we just have to say, okay, but which one belongs here and which one does not? Okay, so going back to this description here. All right, so here we say, okay, we need ERF to be missing. We also need FRE to be missing. Okay. There we go. All right, so we look at 0 0, and then we ask, um, well, right off the bat, we know that 0 0 is going to make the first one, make the negated version of this false, because 0 being E, 0 being F, 0 R 0 is here. So the negation of that is going to be false. So we know that 0 0 does not belong here. Okay, so we can cross that out. What about 0 1? 0 1 would actually not work out also, because 1 0 is here. So that means FRE is going to be true, not true is false. So 0 1 does not belong here, and 1 0 does not belong here either. So now we cross out both of these. What about 1 1? Well, think about it. So if we talk about 1 1, then we have E being 1, F being 1. 1R1 is, well, is it true or not? Do we see 1 1 in R? It is not. Okay, so that means ER 1R1 is false, but not false is true. Same goes for FRE, because both E and F are ones, right? So that means for this one, it is also true. The negated FRE is also true. So we have true and true so far. Is 1 an element of X? Yes. Is 1 an element of X? Yes. So 1, 1 actually would remain in the set. Is that okay? So I think I might have mislabeled what this is about. This is because I think I labeled it earlier as comparable. I think that is still true, because one has to relate to one incomparable. So now we move on to 1 2. Okay, so I think at this point we can start to shortcut the whole thing a little bit. So we know that 1 2 2 1, they both cannot be in this particular set. Okay, so we cross that out. Okay, like that. What about 2 2? 2 2 would belong to the set. Okay, so what about 2 0 and 0 2? They are not going to be in the set. So we take these out. So we have 1 1 2 2 in it. So do we have any questions about this? Nope. Okay. But I have a very strong suspicion that C1 is actually not testing for comparable. It is actually testing whether it is reflexive or not. It's a very tricky way to specify, whether something is reflexive or not. Mm-hmm.
I assumed it was comparable because I assume we're like doing counter, we're generating a set of counter examples for
Mm-hmm.
this property, right? So I kind of did like annotation and then applied
Yeah.
the principle, and then it ended up looking like the comparable principle one.
Yep. Because it's the if you take the negate, yep, it is comparable, because the negation of ERF or FRE is exactly that. Yep. But in this case, it looks like it is testing for reflexivity. Reflexivity. All right. So we'll move on to the next question. All right. So this is question number 2. The C0 and the C1 may not be the same, okay, just because they both, okay, come on back. All right, so this may not be working as well as I want it to be. So if it stops working again, I'm gonna switch back to just typing in an editor. All right, so this one has EF, E is in X, F is in X, and this one is what we saw before. And then this is also, but this one is different. This one says, EF has to be in a set. It is not the case that ERF and FRE implies E equals to F. I think this one is pretty clear of what it is. Okay, so which property do you think is related to C1 in this case? Anti-symmetry. Yep. Because anti-symmetry is the only one that cares about equality. So if you look at the equality where the mouse pointer is, that is the pretty much dead giveaway that this one is looking for counter example of not being anti-symmetric. All right, so C0 is still the same as the other one. I have to kind of think about a way, how to interpret it, because E and F being in a set, they can be one way or the other. Um, so that one I have to think about. But I think the proper way to think about it, as you said, would making an empty set. So I have to think about that a little bit more. But we'll focus on C1. So C1, if C1 returns an empty set, which means the cardinality of the set it returns is a 0, then we have anti-symmetry in this case. So the answer to part 2 is anti-symmetric. R is anti-symmetric. Is that okay? So we'll skip C0 and skip to part 4. In this case, can we find a counterexample that R is anti-symmetric? In other words, we're looking for evidence that R is not anti-symmetric. In this case, 0, 1, and 1, 0, both being in R, makes R not anti-symmetric. Okay, how do we evaluate that? Because if you make E a 0 and make F a 1, okay, so imagine E is 0, F is 1. ERF and FRE are both true because we have 0, 1, and 1, 0 here. So if the left-hand side is true, then we have an implication here. 1 and 0 are not the same. So that means this equality would have given us a false. So we end up with a true implies false. So the implication itself is going to be false. But the entire implication is negated here. So that means, in this case, E being 0, F being 1 would actually qualify it to be a member in this particular set. So the correct answer returned by C1 is going to be a set. And in that particular set, 0, 1 are the elements. So I'm going to write it down. I just need to refresh the screen after I write this down. There we go. And hit a refresh here. And it's not doing it. All right, I'm switching. All right, is it actually working or not? Doesn't look like it's working. So I'm gonna switch gear and just use a normal PDF reader. There we go. So, and then I'm using Notepad or Mousepad to capture the answer. Right. we were working on question number 2. So for for Q2 part 2, the answer is R is anti-symmetric. For Q2 part 4, in this case, the answer is going to be 0, 1 as elements of a set, and the set itself is the element of the answer returned by C1. Is that okay? All right. So now we have question number 3. All right, so for question number 3, once again, we have to look at, C0 and C1 and see whether, how they're defined. The first one is the same as the previous question. So that means in this particular case, when C0 is returning an empty set, then R is anti-symmetric over X. Okay, so we'll answer that question first. That's the easy one. So Q3 part 1 is R is anti-symmetric. Part 2. So in this case, this one is new to us. What do you think? It has got the description of the elements that we are returning is a tuple of EF, but there's a G variable introduced, to qualify, which E and which F we're looking at. So altogether, by the time we evaluate the actual expression that counts, there are 3 variables. So what do you think is the answer? Which property? Transitive. Very good. Okay, so we'll double check and see whether that makes sense or not. All right, so this is basically saying, we have 2 elements, E, F, they both have to be coming from X, which is described here. But we are also picking, there exists an element of X, G, such that EG is in R, GF is in R, and it is not the case that EF is in R. So once again, we're looking for a counterexample of R itself being transitive, but we're excluding G in the counterexample. Okay, we're simply saying that there should have been a direct element of EF, but it's missing, and therefore R is not transitive. Okay. All right. So in this case, okay, first of all, the answer is R is transitive. But when we get to number 3, okay, number 3 is easy, okay, because we're looking for 2 elements that are 2 elements of R that makes R not anti-symmetric. So in this case, the 2 elements which will be merged into one single answer is 0, 2 in a set. And also 1, 2, that is correct. Okay, very good. And then for 4, we are looking for counterexamples that R is not transitive. So the question is R actually transitive or not? What do you think? It is not, and why is it not transitive? Because who is missing? 1, 1 is missing. That's right. So that means for 4, we basically say 1, 1 as a 2 tuple is part of the answer. 2, 2 is fine, I think, because 1, 2, 2, 1. Okay, so 2, 2 is good. 0, 2, 2, 0. So 0, 0 is here. 2, 2 is here. So we're good. But 1, 1 should have been here. 1, 1 should have been here because 1R2 is true, 2R1 is also true, but 1R1 is not true. So that's why we are missing 1, 1. And as a result, this particular relation R is not transitive. So is that okay? Does everybody understand why this R is not transitive for question number 3? All right. So now we move on to question number 4 and also 10. Okay, so 1220. Okay, yep, you're correct. So 10 is also missing. 10 is missing because 2 is here, 1R2 is true, 2R0 is also true, but 1R0 is not true. Yep. Okay, very good. And then for question number 4, for part 1, that's also just checking for transitive. So R is transitive. For part 2, this is the one that we saw earlier. So this one, I'm going to put a question mark here, but I think it has to do with, oh, no, this one we know. R is comparable. Comparable. All right, for 3, we actually have to come up with an answer. The question is it actually transitive? Well, let's see. 1221, 11 is missing. Okay, so we know it's not transitive. So the answer is going to have at least 11 in it. 21, 12, 22 is in here, so that part is good. 21 is here, 10 is here, but 20 is missing. So 20 is also missing in this case. Let's see. 2110, 12, 21, 11 is missing. 10. I think those are the only two in for part 3. And then for part 4, we have 21 or 12. You know, either way is fine because they're in a set. 12 in a set is the answer because we have 12 and we also have 21 in R. Because both of them are in R, R is not antisymmetric. So R is not antisymmetric because of the elements 1 and 2. Hmm? Oh, this one is, you're correct. This one is about comparable. Okay, so we'll, 1. Okay, so let's see. One is an element here because when E is 1, F is 1, 1R1 is missing, negating that is true. 1R1 is missing, the negation of that is true. So that's why 1 is at least one of the elements. So we'll see if there are any other ones. 0 is not going to be an answer. 2 is already here. 0 is relating to, okay, 0 does not relate to 2. So this is, so I'm going to ask and see if you guys would think 20 or 02 is part of the answer or not. So put it here, okay? 0R2 is missing, so the negation of that is true. 2R0 is also missing, so the negation of that is also true. These two are true because we're only considering elements of X to begin with. So that means 20 is here. If 20 is here, then 02 also has to be here because these two expressions here, they are basically quote unquote commutative with each other. So that means if one pattern is here, the other pattern also has to be here. All right. Are we okay with number 4? We good? Okay. So we'll move on to number 5, Q5. All right. So Q5, it has to do with propositional logic. So what is known to be true is given as psi, and it is this particular expression. Fill the following truth table. Okay, so that's the first thing we need to do, which is a little bit on the tedious side. So PQR And we have 1, 1, 1. All right. So for this part, you just have to kind of really just do the calculation itself. So we'll do, I'm spelling out the entire table, and then, which is just binary number count down in this case. Okay. So if you don't want to mentally keep track of all the sub-expressions, you can actually just calculate each sub-expression first so that it's easier for you to look at the entire outcome. So we have P, R, Q, oops, not P, N, R, and Q. So these are basically ended together. The nice thing about conjunction is if at least one thing is false, the entire thing has to be false. So that means there are certain items here that we know has to be false, because whenever R is false, the whole thing has to be false. So I'm just going to pick out all the easy ones first. Same thing can be said about Q. So every time your Q is false, the conjunction also has to be false. So these are guaranteed to be false. So I really only have two items where it can be true or false. So in this case, because P is negated, this one is the false one, and this is going to be one that is true. Is that okay? So I'm not working on the entire thing all at once. I'm working on the sub-expressions first. So the other side of the sub-expression is not R and P. So using the same trick, we just look at all the cases where P is a false, and then we just say these automatically, they all have to be false. And then we look at the remaining ones where R does matter. So when R does matter, we're negating R. So this one is going to be false. This one's going to be false. This one, the one above and below, would be true. Is that okay? And then we work out the implication. Okay, so we have not PRQ implies not P, not R and P. Yep. Oh, right, because we have to negate this entire thing. Well, we can kind of, okay, fine. We'll make a separate column for that, which is just the negation of this column here. So we have 1, 1, 1, 1. The only a 0 here. 1, 1, 1. There we go. So it is correct. So you're correct that this negation applies to this entire conjunction, and this has to be done before the implication, because at the very beginning of the class, we talked about how the implication operator has the lowest priority. So I overlooked this other negation over here. All right, so now we can take a look at the implication, which is only going to be negated later on. So now we have true implies false, which is false. True implies true is true. True implies false is false. True implies true is true. False implies whatever is true. True implies false is false. Then we have false again. Then we have false again. And then the final answer is the negation. Nope, this is the final answer because there's no actual negation to the outside. So we good so far with the derivation of the truth table? Okay. All right, so that's the first part. Filling in the truth table is the first part. The second part of the question says derive the CNF accord corresponding to psi. You can use Boolean algebra and any reasoning that has been discussed in this class, but you must show your steps. Okay, so I'm just going to use Boolean algebra here. Okay, so when I use Boolean algebra, I prefer my variables to be in order. So P, Q, R is going to look like that, and implies P and not R. Okay, so we look at this, and then we Get rid of the implication first. Okay, so we have a negation of, okay, we have the negation of not P and R and Q and R, or P and not R. And then we have double negation. Okay, so let me point out the double negation. Those are double negations. So we can simplify that. So we have not P and Q and R left, and then or P and not R. All right, so now we have a disjunction of CNFs because not P and R, not P and Q and R is a CNF by itself. On the other side, P and not R is also a CNF. When you have a disjunction of two CNFs, you can use FOIL to create a, in this case, a six-term, CNF, but it is guaranteed to be a CNF. So that's what I'm going to do. I'm going to do a 3x2 6-way FOIL. So that means not P is going to be paired with P over here. Not P is going to be paired with not R. Q is going to be paired with P. Q is going to be paired with not R. And then finally, R is going to be paired with P. And then R is also going to be paired with not R. So technically speaking, that's the answer because the question says derive the CNF corresponding to psi. It doesn't say anything about the simplest. So if you stop right here, even though there are very obvious steps that you can simplify this with, since the question did not ask you to do any simplification, you can just leave it like this and go like, this is my CNF. I cannot take a point off because I didn't ask you to simplify. But since we are, since my job is to kind of show you guys what we can do with this, so I'm going to simplify the whole thing. Okay, P or Q, Q or not R, P or R, and this is also another one. So all the ones simplify out. Okay, so we'll take out all the ones, and with only these left. Control C, Control Q, Control V. Let's see, can we do any further simplification here? We can do resolution, okay, but the question also did not ask you to do any resolution. So we can just leave it like this. Any questions about this one? So in other words, if you give me this answer, it's fine, okay? You'll get full credit, but you have to show me all the steps to get there. But if you do any further simplification, okay, I'm not going to take any points off, but you're not going to get any extra points for that either. That's for question number 5. Is that okay? All right, so moving on to question. Yes, go ahead. If I want to perform resolution, then I can, okay. So if I want to perform resolution, I'm going to use the technique that I showed on last Wednesday's lecture, which is basically separating these out because it's easier to visualize which two I'm using for the resolution. So I just call this 1, 2, 3, oops, and 4. All right. So in this case, I prefer the systematic way. So I can look at 1 and 2 and ask if I simplify those two, do I get something new? So if you look at number 5, which is 1 and 2 resolving, if 1 and 2 are going to resolve, P is used as the quote unquote connection. So we are going to have Q or not R left, which is 3. So we already have that. So it's not going to give us anything new because it's just going to give us the same as what we know as number 3. Number 6, 1 and 4 can also resolve. In that case, it will give us just true. So it's not going to be helpful. Okay. Is that okay? Okay, so what else can we do? So we look at the not R of 1 and we say, oh, okay, we can have 1 and 4 to resolve in a different way. But guess what? We still end up with a true. Okay, this part is actually important because somebody who is not paying attention to what resolution actually means would look at number 1 and then would look at number 4 and say, hey, these two, if you resolve these, because this one is the whole negation of this, then we get false. But that is not true, okay? Because the negation of this is actually P and R instead of P or R. So that means these two steps, 1 and 4, can resolve. But in both cases, if you resolve 1 and 4, if you choose P as the connector, you have not R or R left, which is just true. If you use R as the connector, then you have not P or P left, which is also just true. So both of those can resolve, but it doesn't give us anything new or useful. All right, so we are done with number 1. We now look at number 2. So we ask you, what can 2 resolve with? So let's call it number 8. So 2 cannot resolve with anyone because we have um, 3 and 4 do not have a negation of P. 3 and 4 also do not have a negation of Q. So there's no way we can use that. All right, so the only thing left is 3 and 4. Can those two resolve? So let's take a look at 3, 4. They can resolve, because that one has not R, the other one has R. So after these two resolve, we basically have P or Q left. But that's nothing new either because we already had that under 2. So that means, in this case, um, it reaches a dead end. Now, do we want to say anything about psi is not a theorem? We cannot say anything because the question did not ask about proving whether a particular expression is a theorem of another. So even though, yes, you can carry out resolution, you will hit a dead end, but there's no conclusion to say about that particular dead end. Is that okay? So I think this is important, okay, because the context of why we are performing resolution and what conclusion can we draw with that dead end is important. Is that okay? Does that answer the question? Okay. All right, so we move on to number 6. Okay, so here's number 6. All right, so this one says, given that psi is blah, 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 which is already a CNF, do not assume this has anything to do with any other question in this exam. In other words, I don't want people to go back to the previous one and go like, oh, okay, so that's the correct answer to this one. Let me just copy and paste the answer over here. No, that is not the case. Okay. It might coincidentally be like that, but the question specifically said, no, do not assume question 5 has anything to do with question number 6 or the other way around. All right, and then this phi is conveniently the negation of a CNF. Why do you think I said conveniently the negation of a CNF? What do you do with phi if you want to use proof by contradiction with resolution? You have to negate it first, okay? So if you negate phi, you just get the C and F back. So that means there's no need to apply Boolean algebra if I ask the question like this. Is that okay? All right. So the question is, use the following area to show that phi is implied by psi using only CNFs, resolution, and proof by contradiction. You can use Boolean algebra only to prepare for the super CNF, which is the concatenation of the CNF representing psi and the CNF representing the negation of phi. Is that okay? So do you actually have to apply Boolean algebra here? Well, the only Boolean algebra you have to apply is double negation cancels itself out. Okay. You're explicitly allowed to apply absorption, but only when applicable. An incorrect application of absorption will cause point deduction. I don't think absorption is going to help to answer this question since you can choose which two disjunction to resolve. in your answer clearly show how the disjunction are resolved. So I'm giving you the format. So the format that's displayed here is consistent with the format that I used on last Wednesday for that particular homework assignment. Okay, it doesn't have to be exactly the same order. If you want to specify which two are used instead of giving the result first, that's fine. I just need to know which two expressions are being used and what variable are you using for the resolution. All right, so let's move on to the actual answer in this case. So this is for question number 6, Q6. All right, so we're going to spell out all these. Okay, number 1 is not P or not Q. Number 2 is not Q or R. Number 3 is P or not R. Number 4 is not P or Q. And then number 5 is Q or R. All right, so now we can use the resolution. I personally prefer to do things kind of systematically. So I look at number 6 and go like, 1 and 3 can resolve. Okay, so 1 and 3 using P will resolve to not Q and not R, which is not currently on the list. And then right away, I can see that 2 and 6 can also resolve. So I'm sorry that I'm not following my own order because I'm trying to get to the false as quickly as possible. So now we have 2 and 6 using. Okay, which one should I be using if I'm looking at 2 and 6? R has to be the one. Okay, so we're going to have just not Q left. Okay, very good. So if not Q is left, that means if I can somehow single out Q, then I'll be home free. Okay, but I don't see a clear path to do it just yet. So, in other words, the only place that has an R in here is here. So in order to single out this Q, I need something to cancel out the not P. In other words, I have to single out P first. So this is a P, and I got not Q already. I can single out the not P easily. And I'm just looking for a quick way out of here. I can single out the R easily too. Okay, I can see it. All right, so we can single out the P by using I got a not Q, so not P can be singled out. So we'll use 4 and 7 using Q. 4 and 7, that will single out the not P. So having not P by itself gives me the option of singling out the not R. So we can use 3 and 8 using P. That will single out the not R. So now I just need to single out the R. That can be done by using 5 and 7 using Q. That will single out the R. And then I'm done, basically, because between 9 and 10, using R, I will single out, there's nothing left. So now we have a solution of 0. Okay. Are we doing okay so far with these steps of resolution? Do you also see the strategy? Because I'm trying to single out your things so that there's only one term left. Because when there's only one term left, then it becomes a free agent. It's very easy to apply the free agent to anyone who has the opposite of the free agent. So that becomes easier to look at things. It's just, to us humans, it's easier to locate it that way. Okay, so the question is asking, okay, I'm just making sure that I answer all the parts. In your question, clearly shows how the disjunction are resolved. So that's the format, I got that. And I need proof by contradiction. Okay, so at this point, did I apply proof by contradiction? What have I done up to this point? Well, let's count. I have inverted or negated phi so that I have not phi. I converted not phi very conveniently into a CNF. I concatenate the two CNFs to become what I call the super CNF. It's just a longer CNF. And then I apply the resolution and we resolve all the way down to 0. But have I applied proof by contradiction? What would be the outcome of applying proof by contradiction? I mean, it's a proof, right? Okay, proof by contradiction is a proof. So what is the outcome of a proof? What statement should I make in order to make use of proof by contradiction? Yep, exactly. So I can now say that psi and not phi is false. Okay, do we agree? Okay, so if psi and not phi is false, that by itself is not proof by contradiction. I'm simply stating that, oh, okay, things resolve to a 0. So by proof by contradiction, psi and not phi being false implies that psi implies phi. Okay, let me move this over here. And I need parentheses because we have nested implication. So this means, in this case, phi is a theorem of psi. That is the application of proof by contradiction. Is that okay? Yep.
So because we end up with false or 0, we did do the proof by contradiction.
Okay. So arriving to this point is because we use resolution to end up with a 0. Now, resolution, every step we apply resolution is an implicit implication. So what we are really saying is if you look at 1 and 3 together, they imply not Q or not R. And then when you look at 2 and 6 together, they imply not Q and so on. So we have a chain of implication that ultimately connects to false. So everything basically ultimately implies false. But we know the implication itself has to be true because the way we presented resolution, it has its own proof of why it works. So that implication has to be true. So now you have an implication that itself has to be true, and yet it is implying false. So now you have to ask, what do we have to start off with that implies false, and so the implication itself is true? Well, the only time you can have something implies false and the implication itself is true is, okay, think of the truth table of implication. Okay, we need the right hand side to be false. We're trying to figure out the left hand side, but the implication is true. So the only time the only time when something implies false and where the implication itself is true is when you have false implies false. So, okay, so that means, okay, because this allows us to push all the way back to basically say the super CNF, which is represented by this, okay? So the super CNF, which is really just the concatenation of these 5 items, itself has to be false. Is that okay? But what exactly is this? What exactly is the super CNF? The super CNF is a conjunction between psi and not phi. And that's why we know psi and not phi is true. So that's how we come to the conclusion of psi and not phi is false. But proof by contradiction has its own proof, where it says if the conjunction between psi and not phi is false, then we know that psi implies phi, which is the ultimate goal, is to say if psi is given to be true, does it follow that phi also has to be true? Because that really is the whole idea of what is proving a theorem. Yep. Uh-huh. You can use it again. Hmm? Okay, so let's go back and look at number 9. Okay. Okay, so number 9 says, I'm using 3, which is here, and I'm using number 8, which is here, and I'm using P as the connector, so we only have not R left. So the output of resolution itself can be used in further resolution. But what you have used already can still be used. You're not consuming something by using resolution. You're simply saying that, oh, this thing and this thing combined implies that thing over there. But the same thing can be used multiple times. Is that okay? So we got a few minutes left, and I want to go back and clarify, at least to myself, um, if in the first question, basically what this is about, okay? Because I want to look at this expression here and go all the way back to the actual definition of that notation and see whether we can kind of come up with the correct answer. Because I cannot stand it when something is like, we don't exactly know what that means. Okay, so I'm going to convert the whole thing into the notation that we have used before, which is, this is really saying EF is in whatever C0 as a set, if and only if E is in X and F is in X, and it is not the case that ERF implies FRE. And the trick is the for all here. Okay, so we have for all EF. Okay. So now we look at this, and then the for all is really just looking at all the E and Fs, but we have the restriction of E is already confined in X, F is also confined to be in X. So that means if for anything where E is not in X and F is not in X, we don't have to consider those because they cannot make this particular expression true. So the only thing that we have left now to do is to look at all the possible ways of E and F. So EF can be 0, 1, can be 0, 2, can also be 1, 2. So those are the only 3 things left. Is that okay? So now we have to ask, when EF is 0, 1, what is happening here? But EF is the same thing as FE. I think that really is the question, is do we consider this as one case or do we consider it as 2 cases? And we are running out of time. So I'm going to ponder on this one, and I'll definitely answer this one on Wednesday. Because I think this is basically an interpretation issue of, in this particular case, do we think of this one as 2 subcases and they are ended together, or do we consider this as two separate cases, where they are, you know, treated separately? So that's what we'll talk about next on Wednesday. Hmm? Next Wednesday is the test. Monday is a holiday, so that's why we are more than a week out. Yes, Monday is a holiday. All right. So I'm gonna finish the recorder, get it uploaded,